Okay, so today we're going to be talking about physical and chemical changes. And we're also going to be talking about physical and chemical properties. Now this is kind of a big key idea in chemistry. Now what we're trying to determine today, what our big key point, our essential question is, how can you determine whether a change is physical or chemical? Now, when we talk about changes, whether they're physical or chemical, this is the whole concept behind chemistry. Do we actually have a chemical reaction or not? So when we're determining whether something is a chemical change or a physical change, we're looking at their properties. So there are two types of properties. The first one's a physical property. Now what you really need to know about a physical property is it's a quality or property that can be observed or measured without changing the composition. Now, what does that mean? Basically, I'm describing something about an object without making it something new. So I can look at this paper and I can say it's blue. That's a physical property. I can look at it and I know it's blue without changing it. I can say that it's shaped like a rectangle. I can tell that without changing the composition. So the physical properties I can observe, I can see, I can smell, I can hear, I can taste, I can measure, so length, width, mass, without actually changing what it is. So some of those things that we talked about that were physical properties are things like color. Red paper, blue paper, green paper, it's still paper. Solubility. Does something dissolve in something else? Odor. What does it smell like? Density. We're actually going to spend a lot of time learning how to calculate density later in this chapter. Hopefully it's something you're familiar with from middle school science, but I can measure the density of an object without making something new. Melting point. What temperature does something melt at? Boiling point. There are lots of other physical properties, but these are some common ones that we'll be aware of. So a physical property I can observe or measure without changing the substance. A physical change is probably what you would expect a change of a physical property. So I alter the material, and here's the key point, without changing its composition. So if I take this paper and I tear it in half, I have two pieces of paper, but they're both still paper. If I take this piece of paper and I cut it, it's still paper. If I take it and I bend it, it's still paper. So a physical change, I still have the same starting substance. So some of those examples. Cutting, bending, melting, or freezing. Changes of state are always physical properties. So melting, boiling, freezing, evaporation, always physical changes. If I take an ice cube and I put it out on the counter, it's going to melt. It starts as solid water and it becomes liquid water, but it's still water. If I take that ice cube and I put it on a pan on the stove, after it melts, it'll eventually boil. I started with solid water, it turned into liquid water, and then gaseous water, but it's still water. So anytime I'm changing state, it's always physical. So physical properties are things I can see or smell or describe about something without changing it. Chemical properties are a little bit more tricky. If a physical property can be observed without changing the substance, a chemical property has to undergo change. So it's a substance's ability to undergo a reaction. What does that mean? A chemical process or a chemical property is the ability to make something new. That's the big difference between a physical change and a chemical change, or a physical property and a chemical property, is this new substance. So if I have a physical property, it's red paper, it's blue paper, it's green paper, the color doesn't matter. If I have a chemical property, it's not going to be paper anymore. It's going to be something completely 100% brand new. And the property is the ability to make something brand new. So when we talk about chemical properties, an example of my paper for one would be flammability. My paper has the ability to burn. When it burns, it makes something new. I no longer have plain paper. I'm going to have ash. I'm going to have heat. I'm going to have carbon dioxide. I'm making 100% new things. So the property is the ability to burn, the ability to react to make something new. If we were talking about pH, that's something we're going to spend time with second semester. It's the ability to react with acids or bases, the ability to donate hydrogen atoms. It's the ability to change. Reactivity. Some metals rust very easily, other metals don't. That's the ability to react with oxygen to form something new. So all of these are the ability to change. So if we're talking about a chemical change, it changes the composition it makes something new. Now, something that's really interesting about chemical properties, if I'm talking about a chemical property, I can only observe it if there is a chemical change. So I don't know if something's able to burn if someone's never burned it. I don't know if a metal will rust if it's never happened. So I can only observe a chemical property if I also have a chemical change. Do I make something new? If that doesn't happen, then I can't tell. So examples of chemical change, like we said, metal rusting. We could have food that rots. We can have our paper that burns. The food that you ate for breakfast or lunch or dinner, you're going to digest. In each of those situations, I'm taking something and creating something completely 100% brand new. Now, when we talk about chemical changes, there are 4 indicators that a chemical change or a chemical reaction has occurred. So 4 things that we care about. The first is a change in temperature. Now, when we talk about change in temperature, I'm not talking about heating something up. I'm not putting something on the stove. I'm not putting something in the fridge. What happens is I take a solid at room temperature, I dissolve it in a liquid at room temperature, and suddenly my mixture gets super hot. Or I take a liquid at room temperature and I mix it with a liquid at room temperature, and suddenly my mixture gets really cold. So the change in temperature only occurs because I'm combining something, because my chemical reaction is occurring. I'm not actually physically adding heat or taking heat away. It's a byproduct of the reaction. Okay, number 2, change in color or odor. Now again, this is different. I'm not taking clear water and adding red food coloring. If I add red food coloring to clear water, I know it's going to be red. A chemical change has to be an unexpected color change or an unexpected change in odor. So I take a clear liquid and a clear liquid and it turns red. Or I take a white powder and a clear liquid and it turns blue. But I'm getting a color change that I don't expect, that shouldn't happen based on that little color wheel. Okay? Number 3. I can see a change in state. Now we said that a change in state is always a physical change, and it is. But this physical change can sometimes tell me that a chemical change occurred. Now, for example, I might see bubbles. If I take my water and put it on the stove and I get bubbles, no big deal. That's a physical change. I expect that to happen. But if I take a liquid and stir a solid into it and suddenly that mixture bubbles, that's telling me that there's some sort of chemical reaction that's causing the bubbles. If I have a solid form, so for example, I take a liquid and suddenly this solid appears and sinks down to the bottom of my mixture, that shouldn't happen. That's telling me that there was some sort of chemical reaction that caused that change. So again, I'm not adding heat and melting it. I'm not removing heat and solidifying it. I'm actually creating something brand new. The last indicator of a chemical change Irreversibility. Can I change it back? Most chemical reactions, not all, most, are not easily reversed. So let's talk about our physical changes. I take my ice cube, I put it in a glass, I leave it out on the counter, it melts. I can just take that glass of water and put it back in the freezer, and then it'll turn back into a solid. Easy to change it back. A chemical reaction, once I take two liquids and mix them together and a solid forms, it's really usually hard to make that solid go away. So while physical changes are usually pretty easy to fix, chemical changes are usually one way and one way only. Okay? So these are our notes on physical and chemical changes. We'll talk about them tomorrow in class. Make sure you have these copied down really well. If you have any questions, make sure that you ask. Thanks.